Hey everyone, and thanks for joining me today at Cyber Llama Talks. Last time we talked about process emulation and how CPU emulators evolved into a process emulator and how it allowed anti-malware products to detect polymorphic and encrypted malware better. Today we're going to go one step further and you will learn how process emulators actually enable behavioral analysis and allowed anti-malware products to detect polymorphic malware not only by signature, by unpacking polymorphic layers, but also by behavior, by analyzing connection between API calls and the structure of the code. So let me go over with you again very quickly, right? We have a data structures emulated, vCPU, VMM, stack, PEP. I actually forgot one more thing, system libraries. Of course, if shellcode like code is executed, the position independent code is executed, malware also would need to go through the system library to find all the API function addresses it needs to find. It means the process emulator has to emulate loaded libraries inside the process as well, so we're adding it here. Here's again our simplified emulation loop with instruction emulation, API, and syscall emulation. What this new process emulation, what other capabilities beyond unpacking or emulation of polymorphic layer, it actually gives us a lot more. When it goes through API emulations, it creates the list of emulated APIs. For example, a create file, write file, close handle. So we know that this one, a file creation on a disk, if we add the parameters there, and let's say create file uses C Windows /a.exe, we can recognize this behavior as a file creation inside the Windows directory. And for example, by analyzing extension or analyzing content of the write file, we can also conclude that was, for example, a write of a ZPE file. So now we can detect this behavior as, hey, file was created, the executable file was created in the Windows directory. The same thing can happen with this loop of connect, send, receive. If emulator goes through that and emulates the network, then it can send and receive random data and then see what's going to happen. Of course, most likely it's just going to fail because it doesn't actually know the protocol malware talks to C2 with, but at least it can say, hey, that's potentially a C2. Another very interesting thing, to remember to emulate, we also need to disassemble bytes into instruction. Well, what other thing you can do with the disassemble is actually you can disassemble code which was not executed as well. And then combine everything together and build a call graph of what was executed and how, right? So one function called another, maybe there's an if, and so on. If you open the IDA Pro, right, and it shows you the disassembled code, you would see the whole graph of the logical blocks or API calls. You can reconstruct the same one, for example, on API basis, and know what API call after what, in what order, just using a disassemble as well. So it creates a very powerful combination of analyzing emulated APIs with the parameters, as well analyzing the memory which was unpacked during emulation, because after emulation successfully went through a polymorphic layer and decrypted the original payload, you can actually disassemble the whole thing and now see the call graph of all the APIs. And that gave antiviruses a huge capabilities that now the virus analyst could also write heuristics not just on the code, not just the signature, not on the binary itself, but also heuristics on the API calls, both non-executed through the graph and call graph, but also executed with the specific parameters. And that really was this first introduction of the dynamic analysis, which didn't require actual execution. So to summarize, a process emulator added system library and system data structures like PEP, TEP, kernel32, and TDLL emulation, so the data itself exists and can be accessed by the malware. It added API and syscall emulation, including parameter extraction, and of course it couldn't emulate every single API and syscall, so a lot of this emulation would be just stubs which do nothing and just return most probable value. But also it implemented some pass-throughs. For example, for file system emulation, the process emulation could have a virtualized file system where it would allow file creation and read and write to the file, so it actually can keep the context of the malware execution inside. It would also emulate network, even though that probably was still the weakest part, because it could still be beaten by malware by the fact that it could emulate the domain or IP address which is not actually available on the network, and by that expose itself, but it still allow the process emulator to pass through more layers for most of the malware than not. So overall, what it gave us on top of CPU emulator? Well, first, unpacking of custom packers and polymorphic layers. The antivirus engine would not need anymore to recognize the packer and what specific packer it was. At that point, it was not possible because all of them were custom and all of them would consist of polymorphic layers. So process emulator allowed to pass through and actually unpack all of this and apply the signature on unpacked payload, which means the signature now will be much more powerful. It would also allow now a behavioral analysis based on sequence of API calls and their parameters. It could be different heuristics which virus analysts would write. Some of them could be a packer specific. For example, during unpacking, the custom packer could include certain sequence of API which is very unique for that packer. So when virus analysts would add this sequence of API with certain parameters, now the whole class of packers would be detected. So thousands or 10,000s of malware samples could be just detected by one behavioral rule on the packer itself. Or if process emulator is able to go beyond the polymorphic layer and packing layer and also emulate a payload of malware as well, then the virus analyst could write a heuristic to detect the payload as well. Since now the malware was unpacked in the memory, it also allowed control flow graph analysis by analyzing the connection of different code blocks together and also adding the API information into it. So it's kind of mixed between the call graph of the APIs and control flow graph, which can be analyzed and certain structures could be detected inside. Also, between 2005 and 2010, one of the delivery methods which was extremely popular was droppers. That was a type of Trojans which would not do anything malicious themselves, but would just drop another file and then execute it or add it to Authoron. Those type of malware would actually be very easy to emulate because there are not that many API functions they would call. But running them inside the process emulator gives you a really good advantage because by emulating these APIs which drop the file, you can actually have access to the drop file. And then you can also emulate the drop file as well or apply the antivirus signature on the drop file. So it gave also access to extra artifacts. As you can see, the process emulator did not just allow unpacking and reduction of the polymorphic layers. They also opened the gates to do much more sophisticated analysis, such as behavior analysis based on API calls and the parameters, control flow graph analysis, API graph analysis, and drop file detection analysis as well. So very powerful step forward which allow antiviruses to compete with the polymorphic malware. Of course, the process emulator didn't solve all the weaknesses of CPU emulator. We still have a slowness, we still have some incorrect emulation issues, which malware start to exploit, of course. So now next lecture we'll talk about different ways the antiviruses was trying to solve the problem of the slowness of the emulation of instructions. Okay, I hope you learned something new today, and now you know how process emulator actually help and enable anti-malware products, not only to unpack polymorphic malware, but also to perform behavioral analysis of both polymorphic, encrypted, and regular malware, and build detections based on behaviors and API calls and the code structures around it. I hope you enjoyed that episode. Please subscribe, and I hope to see you next time.